Hello, viewers. We have very interesting question under calculation involving molarity. Okay, it's actually a practical question, but they brought it in a theory exam, so you still have to deal with it. So it goes: calculate the volume of 0.100 moles per dm cube potassium hydroxide required to neutralize 12.50 cm cube of 0.100 moles per dm cube sulfuric acid or tetraoxosulfate 6 acid. All right. This is very simple question, but they didn't give us the equation for the reaction because we would need it. That is one. We can see write it ourselves because we need it. Now, the appropriate formula to use for this is our popular Kava formula. Okay, so if we use it, it will be CAVA over CBVB equals NA over NB. Ca is concentration of the A, which is acid in this case, in moles per dm cube. Va is the volume of acid used, or A, in cubic centimeters. Cb is the concentration of B, which in this case is base, in moles per dm cube, while Vb is the volume of pipettes used in cubic centimeters. Then Na is the mole ratio of the acid in the balanced chemical equation, or just A if it is not acid-base titration. Then Nb is the mole ratio of the B or base in the balanced chemical equation. That was the reason I earlier on stated that we need the balanced chemical equation to get our Na and Nb. So from the question again, we are looking for volume of KOH. KOH is the base. So we are looking for VB. To calculate the volume of 0.100 moles per dm cube potassium hydroxide, given that this 0.100 moles means Cb. Okay, that's the concentration in moles per dm cube. It is 0.100 moles per dm cube. Okay, to neutralize 12.50 cm cube, that is the volume of the acid. So Va is 12.50 cubic centimeters. Then Ca, the concentration of the acid, is 0.100 moles per dm cube. All right. So we have everything here. We're looking for Vb, but we don't know our Na and Nb. So that brings in writing the chemical equation. So this is H2SO4 reacting with KOH, which is potassium hydroxide, tetraoxosulfate 6 acid. So it will give us a salt and water. It's neutralization reaction. So it will be K2SO4, potassium sulfate, and water. We need to balance the equation. Hydrogen is 2, 3. It's odd. What if I make hydrogen here 4, and in the B to making hydrogen 4, I put 2 here. All right, let's go. 2 plus 2 is 4, then 4. Sulfur is 1, 1. Oxygen is 4 plus 2, 6. This number affects the everything behind. So oxygen is 4 plus 2, 6. Potassium is 2, 2. So the equation is balanced. So since it is balanced, the mole ratio of the A, acid here, is 1. The mole ratio of the base, Nb, is 2. How do I know? The number in front here is 1, since there is no number. The number in front here is obviously 2. So since we've got this, the next thing would be to make our Vb subject of the formula from this original formula, then substitute all of this and get our answer. Okay, I would need to rub off some part of the board because there is no space. So let me rub this off. Let me rub it off. So if we proceed from here, VB, which is what we're looking for, will be CAVA NB over CBNA. So if we substitute our CA, we got it originally 0.100. VA is 12.50 times NB that we just got that I rubbed off with 2 over CB is still 0.100 times NA is 1. Okay, so let's this will cancel this. So our answer is obviously 12.5 times 2 will give us 25. So VB is 25.0 cm cube, which is naturally the volume of pipette. Okay, it's naturally the volume of pipette used in most schools, although we still have 20.0 cubic centimeter. All right, it is this simple. Okay, it is this simple. I tell you. Remember to like, share, and subscribe to our channel.